Welcome to Module 6 of Getting Started with Hadoop Ecosystem Core Components course. We are going to cover Apache Sqoop, which is an import-export utility in this particular module. So why to learn Apache Sqoop? Apache Sqoop is a utility tool which will provide import-export facility from RDBMS to HDFS and HDFS to RDBMS. So about OdinSchool, OdinSchool is a technology upskilling platform. We help you continuously acquire new skills. So stay skilled, stay ahead. Talking about myself, my name is Tushar Kakaya. I'm having 8 plus years of IT experience working with various forms of data. My main skill set includes MSBI, Hadoop ecosystem components, big data analytics using Apache Spark. I have worked with various tools like Cloudera, SQL Server Management Studio, and my main domain expertise lies in telecommunication domain. So in today's session, we are going to cover data ingestion tools in Hadoop. We will quickly see Sqoop basic architecture. We will import data from MySQL RDBMS to Hadoop HDFS and Hive table, which would be a practical demo. And we will also see a practical demo on how you can export the data from HDFS to RDBMS like MySQL. So what is Sqoop? Sqoop is nothing but a data ingestion tool. Data ingestion tool, that means it will help you to import some data. Now, there generally since years we know like relational database management system, which is nothing but the RDBMS, they are storing all sort of transactional level data. That means your day-to-day transaction, banking, or any order purchase history, all those things you are storing in RDBMS. Now, RDBMS is having data, but basically we have seen in our basic modules like why Hadoop is actually solving this RDBMS big data problem. So basically RDBMS can store humongous amount of data, but processing is actually very tough for RDBMS, and that is the reason Hadoop is there in picture to solve this big data problem. Now, Hadoop is working purely on its distributed file system like HDFS. So there should be some way so that you can import the data from RDBMS to HDFS. And then all your processing components like MapReduce, then Hive, then Pig, all these processing components will take data from HDFS, right? Because for them, the input is HDFS. So there should be some utility which will allow you to transfer data from RDBMS to HDFS, and then further processing engines can actually process the data which is there on HDFS. There is one such utility which is nothing but Flume. But Flume is actually importing unstructured data like log files. Logs are stored behind the scene for every website or any applications. If you want to mine those logs, then Flume can help you. But if you see RDBMS, it is very structured in nature. It is having some tabular structure, rows and columns and tables and all. So those you need to transfer to HDFS. Okay, then there is another tool which will help you, which is nothing but Sqoop. Sqoop is actually made up of two terms, like it is having SQL plus it is having Hadoop. It can actually work with very variety of relational databases such as Teradata, then Oracle, MySQL, even SQL Server, Postgres, okay, and there are many more. So basically there would be some library files which would be kind of acting as a bridge, JDBC drivers which would acting as a bridge between RDBMS to HDFS, because both are having a different architecture. There should be some common thing between them, which is nothing but the driver files which will fill the gap of the data types, or the size, or how the storage is actually defined. All those things would be handled by those drivers. So as I told you, like actual game of analytics, when you say analytics, that means the process of converting data to information is known as analysis, right? So this particular analytics process or game will start when your data is there in HDFS. So data in RDBMS will reflect the transactional level data, but when you want to get some insights from that data set, data should be transferred to HDFS. Sqoop is actually removing this pain of importing and exporting data from or to RDBMS with very simple Sqoop commands. If you see, the utility is giving you very simple interface. Some commands are there, and by simply running that command, it will invoke a map reduce job. But a map reduce job with no reducer. By this, I can say it is only a map job. So Sqoop is a utility which we have already uh, seen this concept in our past modules. Like, there can be one application where reducer is completely optional. When you don't want any aggregation, you don't require reducer, right? Here also, if you see, it's simply a copy operation, right? It's simply a transfer operation from one system to another system. So for that, you don't require any aggregation, you don't require any fancy aggregates like sum, mean, max, right? So here only mappers are required, and number of mappers would actually imply the parallelism in your program. If you are increasing number of mappers, then the amount of data which is transferred from RDBMS to HDFS, that would be faster, because each mapper is handling certain records, certain amount of data to transfer. So basically, as I told you, like, Sqoop will actually convert the commands to a map reduce job, which will be executed over HDFS, and this would be purely map only jobs where no reducer would be there. There are various features also which are provided by Sqoop. Like, Sqoop can actually import full load. That means it can import full database, full tables. It can actually import incrementally also. Like, if you are having any date, and beyond that date, if you want to transfer the data from RDBMS to HDFS, that is quite possible. So incremental load and full load both are supported. It is actually doing parallel import export. Then import results from SQL query is also possible. If you want to just pull the results from a specific SQL query to HDFS, okay, then that import is also possible. Then compression, data compression is quite possible. Okay, then it is having connection with all major RDBMS databases. So you don't actually limit yourself with a few databases, but there are many RDBMS databases through which Sqoop is having the connectivity. Also, it is providing a Kerberos level of security integration. And a very good utility in Sqoop is you are able to load the data directly into Hive or HBase. That is quite possible. So from RDBMS table, let us say you are having a table in RDBMS, you don't want to store in HDFS. You directly want to, bypass and store it into Hive or HBase. That is also quite possible with Sqoop. That is a very good thing, right? Because if you store in HDFS, then create a table on that particular path using Hive, and then you load the data into Hive, that would be quite a cumbersome. So it is giving direct access to Hive and HBase as well. It also supports the accumulo as well. So let us quickly see the architecture of Sqoop. So basically, it will provide you CLI based interface, command line based interface to their end users or client. And you can actually also access Sqoop in your Java APIs also. So there can be a Java class which is able to call the Sqoop commands inside the Java application, so that the fancy applications can also be built. Then Sqoop command which are submitted by the end user. Basically, whenever the end user, let us say this is end user or client which is submitting the Sqoop command, what it will do, it will actually launches a map only job. If you see, it will launch map only job because no reducers are there in Sqoop, because you don't want any aggregation. That map only job will actually connect to the enterprise data warehouse or document based system or relational databases. All these three are possible. It is having a connection. So it will connect with these particular types. And map job launch multiple mappers depending on the number of defined user in the command line. So whatever number of mappers you are specifying, that many mappers would be invoked. And finally, the data would be stored to HDFS, Hive, or HBase. So basically, if you see for Sqoop import, now each mapper task would be assigned with part of data, portion of data to be imported based on the key defined in the command line. You can define the key as well, on which key you want to start the import. So this way Sqoop will basically again do the distributed processing only. Okay, so it will distribute the data among the mappers equally to get the higher performance. Okay, and then each mapper will create the connection with this any of the system which you have specified in the command line using the JDBC driver. JDBC drivers are there. Okay, for each and every RDBMS it would be a different JDBC driver, and it will write the data to HDFS or hive or HBase, whatever you are specifying. Then if we see export utility, then export utility would do exactly reverse thing. Okay, it will take data from HDFS and it will write back to RDBMS. So when we submit our export job, it is again mapped to multiple mapper task, which will bring the chunk of data from HDFS, and these chunks are exported to a structured data destination. Okay, this is very important because Sqoop will never work with unstructured data. Okay, so combining all these exported chunks of data, we receive the whole data, right? Because let us say there are four or five mappers, okay, four mappers, then each one of them will actually um, export the data and then they will load to RDBMS. Okay, so this way you can see most of the cases in RDBMS, like it would be dumped, right? And then it would be dumped into a table basically, and you can actually access the table after that. So your HDFS is no longer needed now. You don't want to confuse your clients by going to HDFS and all these things. That is not needed. Okay, you can simply export data to RDBMS, and if your client is very familiar with RDBMS, why you are bothering now? Because you can export data to RDBMS tables and you can give the results back to client. So all these insights processing or analysis, big data analytics is performed at Hadoop level, but your client doesn't know this, and client assumes, yeah, like output is there at RDBMS. So it would be very transparent, if I say. So let us have a quick demo on the import export utility, and we will use the Cloudera machine which we are using since beginning. So we will be having Sqoop inbuilt in that particular machine. We are having MySQL RDBMS. So we are using MySQL as a RDBMS. We are having several tables in MySQL. Let us import a single table to HDFS using Sqoop import utility, and then we will do reverse thing as well. We will try to know there would be one file at HDFS. We will create a table in MySQL and we will export the data to MySQL. Let us have a quick demo. So let us see how you can import data from MySQL to RDBMS. So I'm having this Cloudera quick start machine where I'm having already this MySQL installed. So I can log into MySQL using this command. Sorry, MySQL -u, which is the username, which is root, and password. Uh, and I'm entering the password now. Yeah, so I'm there in this MySQL shell. Basically, MySQL is RDBMS, and we can have inside that various databases. Inside the database, you are having several, show databases. Command will list out all the databases which are there in MySQL already. I'm interested in this particular database, so I can just use that database. Use classic models. It's use classic models. Okay, and the database is changed. Now if I want to see what are the tables inside this particular database, then I can do the same using show tables command. Yep, and I could see tables in classic models database. There are 3 plus 3 6 plus 2 8, 8 rows. That means 8 tables are there, different tables are there in this particular classic models database. So if I just see one of the tables like select star from customers, then I can see there are 122 records there in this particular table. And this is having some customers data where customer number is there, customer name is there, then customers contact last name is there, contact first name is there, then phone number, address line, 1 2, city, state, postal code, country, then sales representative, employee number, and credit limit. So these all are the fields which are there in the customers table. Okay, and I want to simply transfer entire customers table to HDFS, and I want to do some analysis based on maybe like what is the credit limit, and what is the age wise credit limit or something like that. Maybe anything basically. You just want to retrieve information which is useful for your organization. So in order to import this data to HDFS, basically what we need to do, so we have to just come out of this MySQL first of all, because I just wanted to show you these are the 122 rows which we want at HDFS, right? So I'm coming out of MySQL. So there is a scoop import command. The command syntax is like this: scoop space import, then hyphen hyphen connect. Hyphen connect is an argument, basically some option in this import command. So hyphen hyphen connect, and you can specify JDBC, uh, basically a connection string. So connection string will form like a driver particularly, which is JDBC in this case, colon MySQL. So because the database or SQL Server RDBMS which you are using is MySQL, then colon slash slash and the IP address where the MySQL is there. Right now MySQL is also there in the same machine, so we are using localhost. Otherwise you have to change it to your IP address of the MySQL where the MySQL services are hosted. That IP address you have to give it over here. Colon port number, which is 3306, that is the port number. Then slash, and you will give the database name basically, which is classic models in this case. So if you see over here, classic models, this is nothing but the database which is there in your MySQL, and you are trying to access that particular database. Then hyphen hyphen username. So username is nothing but through which you can actually, or the scoop can log into MySQL. Okay, so username is root, as we had already logged in through root, right, when we opened the MySQL shell. Then hyphen capital P, which will ask the password as the prompt. Okay, then hyphen hyphen and table is an argument which you have to give if you want to copy or import entire table. So in this case we want to import entire customers table, so you will pass hyphen hyphen table customers. Then there is an argument which will decide the number of parallelism in your scoop map only jobs, which is hyphen hyphen m, which means number of mappers. Right now I'm giving only one mapper, okay, because it is a pseudo distributed thing. So only one mapper I want basically, and that's it. This is the command. This is very simple command. As you can see, it will simply invoke or convert this command into a map only job. It will invoke a job. That job will basically do the same thing which we have seen in the map reduce. Okay, it will convert into the key value pair and all those things. But right now reducer will not be invoked because it is a kind of job where only mappers are invoked. Okay, so just press enter, and it would give a warning sign. That is completely fine. And I'll also show you where the library files are there, which is connection between the MySQL and HDFS. That is also we will see. I'll just enter the password for MySQL, and that should be it. Now if you go to your resource manager, it will actually start a MapReduce job. So it has still not started anything. Yeah, now you can see it's running. Running job with this particular ID. Yes, so this is the ID, which is application ending with 0003, and this is the same ID. And yeah, the job is finished. Actually, this is the ID, right? So there are some counter variables. You can see map input records are 122. Now you can relate, right? 122 records were there at MySQL side. The same is transferred. So input records are 122, output records are also 122. These are the bytes which is has transferred, and you can see it has actually done map 0%, reduce 0%, map 100%, reduce 0%, and directly the job is completed. It has not even started the reducer, because Sqoop is kind of a job where reducers are not needed. So these things I have shown you logically what is happening practically. So now what we can do, we will simply start the our file system, Hadoop distributed file system, and we will see the data would be transferred in the HDFS home directory, which is root user and Cloudera. Here you can see customers table was there, right? So there would be a directory named customers automatically. We have not created even. So customers is a directory. Inside that you will see a part file. As you were seeing, like MapReduce job was also generating some part file, right? So here also one part file would be generated, because output of the map reduce job is always a part file. But here there is a difference in the naming convention. The part file is having part hyphen m hyphen 0000. That means this is a mapper generated part file. Okay, let us just download this particular one and just save this file. And now just open this file, part hyphen m000, and you can see everything over there which was there, 122 records, are transferred at HDFS in a comma separated list. So this is the beauty of the Sqoop command. Okay, so like from MySQL you got the data over here. These are having only 122 records, but in real time in production you can have millions of records, millions of transactions which are happening at MySQL level. They are stored at MySQL, they are managed at MySQL RDBMS, and then you can actually get the data over here, perform your analysis and all those things. So because this thing is now very easy for you, because the data is there at HDFS, you can create a hive table on top of it. You can do pig, you can also use any MapReduce job to find out anything, right? Like you just want to see in France how many customers are there, or any analysis basically, which is very uh, you know uh, critical, and it is near to impossible for RDBMS. This is a very small data set, so it would not be a problem, but for big data RDBMS is having a problem to process that huge data set, so that won't be possible, right? So this is the reason basically we are having a Sqoop kind of utilities, which will allow you to transfer the data from RDBMS to HDFS. And now when the data is there in HDFS, you can play around with it. You can play or you can submit your MapReduce job on top of this data. Okay, so this was about the Sqoop import command, a very basic Sqoop import command. Here with hyphen hyphen table argument, basically you can have various arguments also. Like you can actually provide a particular query, and the query output would be resulted into the HDFS file. Okay, so a particular query output only would be transferred to HDFS. That is also quite possible. You can provide the where clause. You can even transfer whole database also. You can also query MySQL databases from here as well. Like we have seen like show databases over there, right, in MySQL. You can do the same from here also. Okay, then if you want to store this particular file at some different location, okay, right now it is storing at root user Cloudera, which is the default directory basically, right, which is the default directory for HDFS, right? So if you want, you can actually provide a different target as well, like hyphen hyphen target directory. So let us try to do the same. Let us provide a target hyphen hyphen target dir. This is the property, and now this time I want to store to root user Cloudera, and there is a folder I think over here which is input data HDFS. Input data HDFS, and you can basically give this particular target directory, and it will again invoke the map reduce job, and it will ask for the password because you have given hyphen p. Even you can give hyphen hyphen small p, and you can provide the password also in the command line or in this particular command itself, but that is not recommended, so I am purposefully giving hyphen capital P so that it can prompt for the password. Again, it is invoking a map reduce job with this particular ID. Yes, it's there, 0004. Yes, map 0%, reduce 0%. It is running. Okay, maps total are 1, reduce is total 0 because no reducers, and maps completed 0 because it is still running. Yes, map is completed. I think the job is also completed. Yes, retrieved 122 records. It will give you the stats as well, how many records it has retrieved. And now if you browse to HDFS, there is an input data HDFS. Inside that, yes, so if you see the one which we have given is Cloudera, right? Instead of Cloudera, by mistake we have given Cloudera. So it has created this particular folder, Cloudera. Inside that there is an input data HDFS directory, and there we are having this part file. So the target directory you can give according to your preference, and it would be automatically created at HDFS level. You don't have to explicitly create them, and then it will import the data to that particular target directory. Then if you want to simply access your MySQL commands at Sqoop shell, then you can do the same, like Sqoop list databases, and then you simply give the connection string which we have given, which is JDBC MySQL localhost 3306, and then the database name, which is classic models, similar like this, username and password. Okay, we have, I think, given the spelling wrong. Databases, and it will ask for the password, and just give the password, and yes, you can see it has actually given this particular list of databases which we were seeing in MySQL show databases query, right? So this is the exactly same result. So this way you can actually list out the tables also from the MySQL side from the Sqoop, so you don't have to actually go into that particular MySQL machine and see which are the databases or tables there in MySQL. So there is an interface between them, and I wanted to just show you one thing, which is this. In the root, in the USR folder, lib folder, there is a Sqoop folder. Inside that there would be a library folder where you will see all the jar files. Okay, so now let us try to import a table directly from MySQL to Hive. Okay, so if you go to MySQL, basically we have seen in the classic models database, we were having other tables as well, right? There was an employee table also. So let us try to simply, you know, see that what are the tables over there. Use classic models and show tables, and there is an employees table, right? So let us try to import this table to a hive table basically, and there are 23 rows in this particular table, and we will import this particular table directly as a hive table. Okay, now let us see what are the options we are having inside the hive shell. So I'll just open the hive shell, and in hive also, if you are aware of, the hive is actually kind of a data warehousing, or uh, you know kind of a storage area, ETL area, where Hadoop is storing the tables in terms of files only, but virtually you can call those files as a table, and the syntax is very similar to SQL, any SQL standard syntax. So that is very much useful for people who are very much familiar with SQL syntaxes, and they can actually access Hadoop HDFS files directly using hive tables. Okay, so it is a very good structured data analysis tool, and here also you can do the same thing, show databases, and here inside this you are having okay, and okay is nothing but acknowledgement, but there is only one database which is default. So let us create database test maybe, so that we can dump that employees table to this test database. So I'm done with this, so I'm again opening one new terminal. I'll just keep that hive shell opened over there. Now the command is sqoop import, and let us connect to MySQL first. So it would be jdbc colon MySQL colon slash slash localhost 3306, and inside that classic models is your database. Then hyphen hyphen username, which is root hyphen capital P. Then there, and if you want particular columns only, then you can specify hyphen hyphen columns. So if you want only 2 or 3 columns at HDFS or hive level, then you can specify hyphen hyphen columns. Okay, right now I want entire table, so hyphen hyphen table, and the table name is employees. Okay, then I will give a target directory as well, which would be root user Cloudera and employees Sqoop. Okay, then I can actually give fields terminated by, which is a delimiter, which I'm giving as comma, then hyphen hyphen hive import. Then you can actually specify whether you want to create that hive table if it is not already there. So we don't have that table, so we will create the hive table, and you will just specify the destination hive table, which is test dot, and we will give the same name, employees. So this will again invoke a map only job. Okay, it is giving us some error like classic models dot employees doesn't exist basically at MySQL end. So let us quickly check whether we have given the correct name or not. Employees. Let us try with the small letters. Yep, I think that was the issue with the case sensitivity. So we just try to, give the small letters employees, E with a small letter. So it is starting a job basically. It has done number of splits is equals to 4. It has started the map reduce job, which you can see again from here as well. Okay. Yes, there is a job running with 005 as the ID. Okay. So basically it will try to, invoke this hive configuration also. You can see hive log 4 properties. Number of files are 4 because it has done 4 input splits. You can actually specify the split by as well, split by, and you can specify a particular ID column or something. So it will split by that particular column. Okay, so time taken is 1.277 seconds, and here it is basically loading data to table test.employees. You can see over here, right? So now if at hive shell, if we simply do select star from test.employees, then you should be able to see these records over here. Okay, it fetched 23 rows, and if you see, this is the beauty of this kind of Sqoop utilities, which will allow you to transfer the data not in HDFS but in hive table directly. Okay, so you just don't need to you just don't need to load the data specifically in a particular hive table on top of HDFS. So that is not at all needed. Your hive table is actually getting created also within Sqoop utility. So this is a very good utility, useful utility, which will help a lot in real time production environments. Now let me introduce you to the Sqoop export utility. Basically, this is the command which will help you to export the data back to back from HDFS to RDBMS. So until now we have seen like the data can be transferred from RDBMS to HDFS, right? Now we are doing the reverse thing. Data is there at HDFS. Maybe you did some map reduce job or something, and your output is generated, at HDFS level in terms of part file or something, right? And you just need to, copy that data to MySQL. But if you see, MySQL is having a different architecture. So the MySQL is actually an RDBMS with, tables and rows and columns. So uh, in that way, what we need to do, uh, we need to create the table first, which would match exactly as the schema of your file, as the columns of your file, fields of your file. So you will create a table first at MySQL, which will be having all those columns which are there in your file. And that way you can make sure like your schemas are up to date at both end, HDFS and MySQL, right? Because here it is a file, there it is a table. And you can actually specify the delimiters as well using hyphen hyphen fields terminated by option. Okay, and that way export command will help you to export the data from HDFS to MySQL. Let us do this exercise. It would be very interesting to see how the data is transferred. So what I'm doing currently, I'm just creating a simple student data. Let us say 100 is the student ID. I am just giving some random name like Ram, which is having a subject Hadoop, and he is from India, the student city. Then 104, let us say her name is Sita, who is learning SQL Server, and she is from also India. Then 108, the name is, let us say, uh, Neil, who is learning C sharp and who is from USA. Then let us say some 167 student ID whose name is Richard. Okay, and he is learning, let us say, DW data warehouse, and he is from Australia. Okay, for simplicity, I'm having these four records as of now. Okay, you can have a very big file, you can have a part file also, which is generated as a mapper output. That is completely fine. You just need to save this file to your home folder with the name student data dot csv maybe. Okay, so we are having a file in our root home cloudera home folder, student data dot csv. Now what we need to do, basically we just need to go to MySQL. We will do the same exercise, and I am there in MySQL now. Here I need to first create a table which is matching the schema and field names and all from my file which I have created. So create table, and I will create a table students with very first field is nothing but student ID, which is, let us say, an int column. Then student name, let us say it is a character of 20. Then I'm having a student course which he has taken, which is also having, let us say, character of 20. And then finally the student city, which is also again a character of 20. So this way I have just created a simple table. Okay, and no database is selected. Yes, I need to select use classic models. So now the database is changed, and I'm creating a table inside the classic models. So if you now just uh, select, do this select star from students, you won't see any result because it's an empty set, right? Now what I am doing in another shell, let me clear this out. In another shell, what I'm doing, I'm actually writing an export utility. So Sqoop export, then we will connect using the same connection string, but here the uh, option is different. It's an export option, right? So JDBC MySQL, then localhost 8030, and finally we will give, just a minute. Yeah, so you may be wondering why I have given 8030 over here, because that is nothing but uh, uh, your HDFS services. So let us try this out, otherwise we'll change the port and the IP address. IP address would be same, but we can change the port later on. And classic models is the database hyphen hyphen username, which is root hyphen capital P, and we want to store to students table, and we will give the export directory here, which is something we need to upload, right? We have to upload this file which we have created, student data, to any HDFS directory. For that we will do Hadoop or HDFS DFS hyphen put, and we will be having student data dot csv. Let us put to root user Cloudera. Inside that, input data HDFS directory. So we just need to upload the file to HDFS, right? And that's what we are doing currently. Now let me just check whether the file is there or not in the root user Cloudera input data HDFS, and yes, I'm having a student data.csv file. There are two files, but this is the one which we have just created, 24th August, which is today's date. So student data.csv, this file is there. Okay, now I just need to give the path in the export directory, root user Cloudera input data HDFS slash student data.csv, and yes, it should start the MapReduce job again to export data. This would be a reverse procedure. It will connect to MySQL now, and it will check this table is there or not in this particular database. It will check the schema and all. Okay, so you just need to be sure, otherwise you will face some errors also, right? So you just need to be sure the schema is matching correctly. You can actually even see the applications, and still the application is not even submitted or accepted. Maybe it is doing some schema check. So it is in this beginning code generation stage where it is converting the code, or this utility will convert all these things into a MapReduce job. Okay, and if this is failing, then there are high chances the port number given is incorrect. So we will just see if it is failing. Then if it is failing, then we will definitely change the port number which we are using until now, which is 3306. And the default field delimiter is comma, guys. So you just need to be sure. If your file is tab delimiter like mapper output, always MapReduce output would be a tab delimited file. So you just need to specify hyphen hyphen fields hyphen terminated by option, and just give tab slash t. So maybe it's simply not working because of that incorrect port number. So what we will do, we will use the same command, but we will change the port number. It is 3306 mostly. Let us check for the other commands as well which we have given. Yes, localhost colon 3306, and classic models is correct. Okay, so we can try with this way, and hopefully this should work now. Yes, Now you can see no columns to generate for class writer. That is an IO exception. So at least it tried to connect to MySQL. So very first thing it is doing is connecting to MySQL, and you can see it is giving you some sort of exception like MySQL syntax error exception, like this table doesn't exist, that is your error, right? So uh, basically what you need to do, you just need to check whether inside the classic models the students table is there or not. So we have, I think, created, but if any error is there in the just in the spell or something, yeah, in the case sensitivity also, right? Because MySQL is having this particular convention. So S is capital at the time of creation of the table, and you can see it is given a small letter S over here, so that maybe the problem is. And let us simply change the table with capital S students, and this should work now hopefully. And it is again asking for the password. Yep, it has actually started the MapReduce job, connecting to resource manager. Yep, and it has submitted one job which is 006. And if you see all applications now, it is in accepted state. Now mostly it should be in running state now, because it is in running job over here. So it should anytime come in this running applications state, which is this. Okay, students.jar is the name of the application. By default the framework has given this name, and it is starting the map reduce job with no reducers. And in fraction of seconds this job should also be completed. You can actually see the progress over here by opening that particular application master for the application ID. Yep, it's in running state with 4 total maps. This is completely framework's decision. You can also specify hyphen hyphen m, which will give you the freedom to choose number of mappers also. Yeah, the job is completed. Okay, and it transferred 965 bytes, and it exported 4 records. Okay, so now what we will do, we will simply go to MySQL, we will run the same query, select star from students, and bingo, our output is actually correct. It has transferred that student data.csv file, which was a CSV file at HDFS end. Okay, and it transferred it to students table. So this is a very simple utility which will help you a lot in real-time environment. So let us have a quick recap what we have learned in this particular module. We tried to learn the data ingestion tools which are there in Hadoop, and basically the most important tool for structured data ingestion, which is Sqoop. We saw the Sqoop's basic architecture. We imported some data from MySQL RDBMS to Hadoop HDFS as well as to a Hive table. We tried to export the data back to MySQL table from an HDFS file. So this is all about this module. Thank you very much for staying with me. Don't forget to like and subscribe.